Hi everyone, welcome back. In this video, we are going to learn integration in kinematics of linear motion, determining and interpreting the instantaneous velocity of a particle from its acceleration function. First of all, let's recall. Previously, when we are given a velocity function, let's say 3t squared plus 5t, if we want to find acceleration, we have to do differentiation. A equals to dv dt. So we differentiate term by term, we have 6t plus 5. So A equals to dv dt. Now, how about we need to do the other way around? Let's say we are given an acceleration function and the question asks us to find back velocity. So from velocity to acceleration, we have to do differentiation. That means from acceleration, if you want to find velocity, we have to do integration. So V equals to integrate of A dt. For example, A equals to 6t plus 5. Let's say I take the answer just now. From acceleration, if I would like to find back velocity function, I have to do integration. V equals to integrate A dt. So we have V equals to integrate 6t plus 5. After integration, we have plus c at the back because this is an indefinite integral. Usually, the question will give us some information to find the value of c. After we substitute the value of c inside, then we will have a complete velocity function. Okay, so this is the conclusion. From velocity, if you would like to find acceleration function, we have to do differentiation. Then, from acceleration, if you would like to find back velocity, you have to do integration. Let's try a few examples. Example 24. A particle moves along a straight line and passes through a fixed point O with an initial velocity of 4 meters per second. Its acceleration is given by A equals to 4 minus 2t. Calculate the instantaneous velocity of the particle when t equals to 7. So we are given an acceleration function and the question asks us about velocity. From acceleration, if we want to find velocity, we have to do integration. Integrate A dt. And A for this question is 4 minus 2t, so I substitute here. So V equals to integration of 4 minus 2t dt. So we do integration. And since this is an indefinite integral, so that's why we have a plus c at the back. Okay, 2 and 2 cut. So we have a velocity function, v equals to 4t minus t squared plus c. And let's check whether there is an information to help us to find the value of c or not. So we notice that they give us initial velocity equals to 4. That means when t equals to 0, v equals to 4. So we substitute v, we sub 4, and t, we sub 0. So we have answer c equals to 4. So 4, we substitute back into the velocity function. So here's the complete equation of velocity function. Then let's read the question again. They ask us to calculate the instantaneous velocity when t equals to 7. So now you just have to sub t equals to 7 into the velocity function. And we have v equals to negative 17 meters per second. Next, calculate the maximum velocity of the particle. Okay, whenever we see the word maximum, we have to do differentiation and let it be 0. Maximum velocity. So we do differentiation for velocity, means dv dt, and let it be 0. So for v maximum, dv dt is 0, and dv dt is a. Okay, then a is given. A is 4 minus 2t. So 4 minus 2t equals to 0. Then we have answer t equals to 2. And let's read the question again. They are asking maximum velocity. The meaning of t equals to 2 is 2 is the value of time that make velocity maximum. So now you just have to substitute t equals to 2 back to the velocity function. Then we have answer velocity is 8 meters per second. Okay, then the best answer is, please prove that it is really maximum. So to prove that velocity is really maximum, we have to do second order derivative. So dv dt is 4 minus 2t. We differentiate one more time. Differentiate 4, answer 0. Differentiate negative 2t, answer negative 2. So we have d2v dt squared, answer negative 2, which is less than 0. That means negative. When you have second order derivative less than 0, that means you prove already velocity is a maximum. B, find the possible values of t in seconds when the velocity of the particle is 7. So this is the velocity function when v equals to 7. So we let this be 7. So 4t minus t squared plus 4 equals to 7. And then we do general form. Because a is negative 1 here, so I bring all the term to the other side. That's why we have t squared minus 4t plus 3 equals to 0. Then we do factorization. So we have answer t equals to 1 and t equals to 3. Example 25. A particle moves along a straight line and passes through a fixed point O with an initial velocity of 10 meters per second. The acceleration of the particle is given by a equals to 4t minus 8. Find the instantaneous velocity of the particle at the 4th second. So we are given an acceleration function and the question asks us velocity. So we have to do integration. So v equals to integrate of a dt. A is 4t minus 8. Then since this is an indefinite integral, after we do integration, there will be a plus c at the back. So 4t squared over 2 minus 8t plus c. I simplify first. We have v equals to 2t squared minus 8t plus c. Then to find the value of c, we check the information given. Initial velocity 10. So when t equals to 0, v equals to 10. So we substitute v 10, t 0. Then we have answer c equals to 10. So this is the complete equation for velocity function. V equals to 2t squared minus 8t plus 10. And then let's read the question again. They ask us to find the instantaneous velocity at the 4th second. So we just need to substitute t equals to 4 into the equation. Then we have answer b equals to 10 meters per second. B, find the minimum velocity of the particle. Whenever you see the word minimum or maximum, that means you have to do differentiation and let it be 0. So minimum velocity, we have to do dv dt and let it be 0. So dv dt equals to 0. dv dt is a. So a equals to 0. A is 4t minus 8 in this question. Let it be 0. We have t equals to 2. So t equals to 2 is the time in which velocity is minimum. So we just have to substitute t equals to 2 into the velocity function to find the minimum velocity. This is the velocity function that you found. So we just have to sub 2 here. Okay, then let's prove that velocity is really minimum. dv dt is 4t minus 8. We have to do differentiation one more time. Differentiate 4t, answer 4. Differentiate number, answer 0. So d2v dt squared is 4, which is a positive number. That means greater than 0. That means we prove already velocity is really minimum. Let's try example 26. The acceleration of a particle is given by a equals to 60 minus 24. The particle passes through O with a velocity of 36 meters per second. Find the range of values of t when the velocity is negative. Velocity is negative means v less than 0. To be able to apply this inequality, you have to firstly find the equation of v. Then we notice that the question gives us a. So from a, if we want to find v, we have to do integration. So v equals to integrate a dt. That means integrate 60 minus 24 dt. Okay, we do integration. There is a plus c here because this is an indefinite integral. I simplify 6 divided by 2. We have 3t squared minus 24t plus c. Okay, I simplify so that it's easier for me to do substitution later. Okay, to get the value of c, let's read the question again. A particle moves along a straight line at t seconds after passing a fixed point O. That means when it starts moving, means t equals to 0. At the fixed point O means s equals to 0. Then the particle passes through O with a velocity of 36 meters per second. So this means when s equals to 0, v equals to 36. Since when s equals to 0, t is actually 0. So we conclude this means when t equals to 0, v equals to 36. So that's why I substitute v 36 and t I sub 0. So we have answer c equals to 36. So we substitute back the value of c into the velocity function. So we have a complete equation of velocity, 3t squared minus 24t plus 36. Then let's read the question again. Find the range of values of t when the velocity is negative. So now, finally, we have the v equation. That's why we can apply already, v less than 0. So 3t squared minus 24t plus 36 less than 0. Then I divide every term by 3, and we do factorization. Then since this is an inequality, so I have to do graph sketching method. So the t-intercept are 2 and 6. Then we check the symbol less than 0, means we have to choose the value, the graph that is below the x-axis. So we have to choose t in between 2 to 6. B, find the minimum velocity of the particle. Whenever you see the word minimum or maximum, we have to do differentiation and let it be 0. So minimum velocity, that means dv dt equals to 0. So I do dv dt equals to 0, and dv dt is actually a. So a equals to 0. A is 16 minus 24, so we sub here. Then we do algebra. We have t equals to 4. So the meaning is when t equals to 4, this is the time in which velocity is minimum. So to find minimum velocity, we have to substitute t equals to 4 back into the velocity function. So here we sub 4. Then we have answer v equals to negative 12 meters per second. Okay, then to play safe, let's prove that the velocity is really minimum by doing second order derivative. So let's check. dv dt is 16 minus 24. So we differentiate one more time. Differentiate 60, answer 6. Differentiate negative 24, answer 0. So we have d2v dt squared is 6, which is a positive answer greater than 0. When d2v dt squared is greater than 0, that means v is minimum. So you prove already the velocity is minimum. Example 27, stitching patterns on the straight edge of a headgear is done by a sewing machine. The initial velocity of the sewing machine is 20 cm per second. The acceleration is given by a equals to 8 minus 2t, and then calculate the instantaneous velocity of the sewing at the second. Okay, so we are given an acceleration function and they ask us velocity. So we have to firstly do integration to get the velocity function. So a equals to 8 minus 2t. V is integration of a dt. A is 8 minus 2t. So we integrate, and there is a plus c at the back. So let's check the information given. They said initial velocity is 20. So that means when t equals to 0, v equals to 20. Okay, so we can substitute here. T we sub 0, v we sub 20. So c equals to 20. 20 sub back into the velocity function. So we have a complete velocity function, v equals to 18 minus t squared plus 20. After that, let's read the question again. They ask us to find the instantaneous velocity at the second. So that means what's the answer for velocity when t equals to 2? So we substitute 2 into the velocity function. Then we have answer v equals to 32 cm per second. B, calculate the instantaneous velocity of the sewing when the acceleration is 0. So when a equals to 0, we try to find back the value of t, and we use the t value to find the answer for velocity. Okay, so when a equals to 0, 8 minus 2t equals to 0. So we have answer t equals to 4, and they are asking instantaneous velocity. So we sub t equals to 4 into velocity equation. Okay, then we have answer v equals to 36 cm per second. C, calculate the time in seconds of the sewing when the acceleration is 5 cm per second squared. So when a equals to 5, we have a equals to 8 minus 2t. So 8 minus 2t equals to 5. Then just bring over, we have t equals to 3 over 2 or 1.5 seconds. D, find the value of t in seconds when the velocity of the sewing is 11 cm per second. So when v equals to 11, this is the v equation that we found. So 18 minus t squared plus 20 equals to 11. And then since a is -1, so I bring all the term here to the other side. So we have t squared minus 8t minus 9 equals to 0. Then we do factorization. Then we have two answers for t. And since t cannot be negative, so we put ignore for t equals to -1. So the answer is only t equals to 9.